Good afternoon, kiddos. Today we're going to talk about section 5.8, triangle proofs. If you have the copy of the notes, that's great. If not, you can either print them off of Canvas or you can just write these directly in your composition book. Just hit pause at the beginning of each page so that you have time to write the proof in your notebooks. Today's objective is to use side angle side, side side side, angle side angle, angle angle side, or hypotenuse leg to show two triangles are congruent. This can be referenced in your book on pages 222 through 250. All right, a few things you need to know about triangle proofs. First of all, every statement must have a reason. So if you say something, you absolutely, positively must tell me why you chose to write that statement on your paper. 2, in order to have congruent triangles, you have to either have 3 congruent parts for side angle side, side side side, angle side angle, or angle angle side that can be used, or if you're using hypotenuse leg, you must have one right angle and then a congruent side and a congruent hypotenuse. So the hypotenuses have to be congruent and one pair of the legs have to be congruent. And last but not least, you can do 2-column proofs like we did back at the beginning of the year, or you can do flow proofs. So today I'm going to go through and show you flow proofs just to give you a different perspective. So let's take example 1. So example 1, they tell you that T is the midpoint of segment SW and that segment SR is parallel to segment WX. And we're going to prove that the two triangles SRT and triangle WXT are congruent. So to do a flow proof, the first thing we're going to do is to write our first given statement. So I'm going to come over here and I'm going to write T is the midpoint of SW. And I'm going to put a little box around it. And below my box, I'm going to state how I know that T is the midpoint of SW. I know that T is the midpoint of SW basically 100% because it's given to me. I am going to mark that on my picture, so I look at segment SW. I find my midpoint T right here, and that means that this is going to be congruent to this. So I look at this, I look at my picture, what does that tell me? Going back to the beginning of the year, what is the most important vocabulary word? The most important vocabulary word in that statement is midpoint. So what do midpoints do? Well, midpoints tell us that we have congruent segments. So by looking at the picture, I can tell that segment ST is going to be congruent to segment TW. And I'm going to put a little box around that. I'm going to ask myself, okay, how do you know that? I know that because of the definition of midpoint. So when I think of the definition of midpoint states it's a point that forms two congruent segments. So at that point, I look and I have a pair of congruent sides. So I have a nice statement. I'm going to leave it and I'm going to go on to my next piece of information. So up here, I'm done with this first piece of information. So I'm going to come down and I'm going to write my second given. SR is parallel to WX. I'm going to mark that on my picture. And I'm going to ask myself how I know that. I know that literally because it is given to me. So I have this given statement, wrote it down. Let's see where it takes me. If you recall back to the beginning of the year when we talked about parallel lines, we talked about our favorite thing, the magic Z. So if I look at the magic Z right here, here's my magic Z. And the little armpits of that Z are going to be congruent. So like right here and right here, I have two congruent angles. So I can say that angle S is congruent to angle W. And I know that because if two lines are parallel, then alternate interior angles are congruent. And there's really no short way to write that. I wish there was, but we're just going to write the whole statement. So now I have a pair of congruent angles. So I have to look at my picture and I have to decide, okay, is there anything on my picture that I see that I could use? Technically in this picture there's going to be two things we could use. I'm going to pick one of them. I'm going to say that right here, that this angle here is congruent to this angle here because they are vertical. So I can come down and say that angle STR and angle XTW are vertical angles. How do I know that? I know that because of the definition of vertical angles. And then what do we know about vertical angles? Well, we know that they are all congruent. So we can say that angle STR is congruent to angle XTW because vertical angles are congruent. All right, so now I have another pair of congruent angles. So if we look at what's going on right now, I have a pair of sides that's congruent, a pair of angles that are congruent, and another pair of angles that are congruent. So technically I have three congruent things. They are in a good order on my picture. So I can combine this statement, and this statement to say my final congruent statement. Now, one thing about your final congruent statement, whatever you have written up here is what you want to write right here in this box. So there's no reason to go guessing. Don't change the order of the letters. Just copy that statement directly. So we're just going to say that triangle SRT is congruent to triangle WXT. And how do I know that? Oops. How do I know that? You're going to look at your picture. And when you look at your picture, you can look and you have angle, side, angle. So my reason for this is going to be angle, side, angle. And at this point, I am done with this proof. Okay? Now, on this particular proof, one thing you could have done, you could have used the alternate interior angles to show that angle R and angle X are congruent. And if you would have used that right here as your third step, you would have used the reason angle, angle, side. And for this particular proof, there are two legitimate reasons for how come these two triangles are congruent. So let's go to the next problem. All right, so looking at example 2, I want you to take a minute. I want you to hit pause, and I want you to see what you can do. All right, welcome back. So looking at what I know here that XY is congruent to WX. So I'm going to mark that on my picture. XY is congruent to WX. Those of you who do not mark stuff on your picture, that is your loss. You really should do that. It helps you identify the reason. Done with that piece of information. That is actually a set of congruent sides. All right, the other thing I know is YZ is congruent to WZ. And again, YZ is right here, WZ is right here. I know that because it's given. Some of you will ask if you could actually put that in the same box. Yes, because those are both already have congruent signs and they're kind of dead-end statements. I have no problem with you putting those in the same box. Now, looking at your picture, I come up, I look at my picture, and I notice I have this segment XZ right here. And we have gone over this a lot, that XZ is actually congruent to itself. So XZ is congruent to XZ, and I know that because of the reflexive property. And by looking at my triangle and looking here, I can look at my three things that I've written. I have a congruent sign here, I have a congruent sign here, and I have a set of congruent sides there. So if I want to combine these three statements, I can combine those three statements to write my final congruent statement. And again, whatever you have right here is what you want to put right here. So copy that statement exactly. So triangle XYZ is congruent to triangle XWZ. And the reason those two triangles are congruent is because I have three pairs of congruent sides. So I'm going to use the side, side, side method. Let's tackle a little something different. Okay, So looking at example number 3, AD bisects EC. This is going to be a little bit longer, so I'm going to use my extra space up here. So AD bisects EC. Because there is no congruent statement here, I'm going to not combine that with my other statement. So when you look at the definition of bisectors, bisectors intersect a segment at a midpoint. So that tells me that M is the midpoint of EC. And again, you may have to get your books out and look up exactly what these words mean. But if we think about that word right there, and I think about the reason I'm going to put right here, that is because of the definition of bisector. Now, looking at my picture, if M is the midpoint of EC, here's E and C, and I don't know why I said M, that should have been B, so I'm just going to go correct that right now because I'm not recording this whole slide, sorry. So B is the midpoint of EC. Alright, so if B is the midpoint of EC, that tells me that EB and BC are congruent. So I know that segment EB is congruent to segment BC. And again, I'm going to look at my statement. Here I have midpoint. This is going to follow directly from that key vocabulary word. So this will fall into place as definition. Definition of midpoint. Alright, so now if I look at my statement, I have a pair of congruent sides, so I'm really kind of done with that piece of information. I cannot take it any further. So my next statement that is given to me says that B is the midpoint of segment AD. And if I think about how I know that B is the midpoint of AD, it's right here, it's given to me. So I'm going to write given, and I'm going to cross that out so I don't look at it again. I'm going to go to my picture, and if B is the midpoint of AD, here's A and here's D, so that means that these two segments are going to be congruent. So again, looking at key vocabulary words, here's my key vocabulary word in midpoint. So I'm going to write that AB is congruent to BD. This is pretty messy. And the reason I know that is the definition of midpoint. So that follows exactly from that keyword. You're going to use that keyword as the reason right here. And when I look, I have now proved another set of sides are congruent. So now looking at the picture, I don't know for sure that AE is parallel to CD, but the one thing I do know is that this angle here and this angle here are vertical. So I'm going to go rolling with that plan. So I'm going to say that angle ABE and angle DBC are vertical angles. And I know that because of the definition of vertical angles. And because those two angles are vertical, I know that they are going to be congruent. So angle ABE is congruent to angle DBC because vertical angles are congruent. And again, whatever your key vocabulary word is right here is what's going to be used as your follow-up right here. So now I can take and I can combine these three statements, uno, dos, tres, to write my final triangle congruent statement. And once again, I'm going to come up here to the very top. Whatever statement I have here is what statement I am going to write here. So triangle ABE is congruent to triangle DBC. And how do I know that? Well, how do I know that? Over here, I have a pair of congruent angles. I have two pairs of congruent sides. So if I look at the order on the picture, I have side, I have an included angle, and I have a side. So here I have side, angle, side. All right, at this point, I want you to look at proof 4, and I want you to see what you can figure out on proof 4, and this is where we will pick up tomorrow when you come to class. Have a great evening, and I look forward to discussing example 4 when I see your bright, shiny faces in class tomorrow. Have a great night. Bye-bye.